It is a GATE 2020 question from the subject called compiler design. Here two grammar productions are given, first and second. And first production with two alternatives, second production is one alternative. Here the question is number of reductions taken by a bottom-up parser while accepting the string AAADBBB is a string. So means how many steps are required, means how many number of reductions are required to parse the string given. Here I am writing the string AAAD and triple B. Here the approach to be used is bottom-up parsing technique. Bottom-up parsing technique construct a parse tree starting from the input and reduce this input to starting non-term. Reduce this input to starting non. This process is called reduction process. We call it is reduction process. In the reduction process, it requires to identify the handles in the sentential form. Here I am using one word called handle. Handle is nothing but RHS of a production. RHS of a production need to identify in the input sentence, in the derivation step. That RHS of a production need to be replaced with its left hand side. This process is called reduction process. We also called it is handle pruning technique. What it will do in handle pruning is it will scan the input from left to right and stop the process. Scan the input from left to right and scan the process as soon as it sees RHS of some production. Here for this step, at this step, I can find, when I'm scanning from left to right, I can find a handle D in the input AAAD triple B. So because D is a RHS of a production S tends to B, so that this D is going to be replaced with S. This is called a reduction process. We also called handle pruning. Now after replacing the D with S, now my input string is AAASBBB. First reduction is over. This is called reduction number 1. Now it will repeat the process of scanning the input from left to right to identify the RHS of some production. It scans the input from left to right and identify the RHS of some production. Here I found RHS of some production B tends to B. Here S tends to D, okay. B tends to B. It is a second one. Now it requires to replace this B with its LHS capital B. So the string becomes AAAS. This B is replaced with capital B, and we also have two B's. Again the process is repeated, scanning from left to right and stop the process as soon as it finds a handle. Now here it finds a handle called S tends to ASB. As soon as a handle is found, perform the reduction, means replace RHS with its left hand side. After replacing RHS ASB with S, will have the sentential form 2As. This ASB completely is replaced with single S and we have 2Bs. Again repeat the process of scanning the input from left to right and stop as soon as you find a handle. Here in this situation the handle is B tends to B. This is the fourth step in the reduction process. So after reducing AASBB, now the resultant sentential form in the process is AAS. This B is replaced with capital B and small. Now again repeat the process, scan the input from left to right. Here we find the handle S tends to ASB. This is the fifth step. Now replace S tends to ASB, means replace ASB with S. Now the resultant string is ASB. Again repeat the process, scan from left to right, stop the process whenever the handle is found. Here the handle is B tends to B matching. This is a sixth step. Replace this B with its left hand side capital B. The string after the reduction is AS capital B. Again the process is same, scan the input from left to right and stop whenever the handle is found. Here in this step we have a handle ASB matching with the production, S turns to ASB. Now this is the seventh step, and prune the handle means replace its RHS with left hand side so that it is going to be reduced to S. Here in the bottom up parsing technique, we have to start with input and reduce this input in a series of handle prunings to the starting non-terminal. This complete process we call it is reduction process. In this reduction process, to reduce this input to the starting non-terminal, how many steps are required? 1, 2, 3, 4, 5, 6, 7 steps are required. So answer for this question will be 7.